industrial is called a glandular connector. Whenever you are getting an input or an output over there in a cabinet, you don't leave just the hole. You get a connector like this, or you use conduit too, like this one that we have over here. So is the inlet of power, is the outlet over here for the motor. The connection is a little bit damaged. I tried to fix it, but well, I tried to do my best. So in general terms, for this one, we have a general disconnector. This implementation is quite a little weird, but I hope you can have a really good idea on a real industrial implementation. Why? Because in this one, you need to open it and then you need to activate it. But I guess you can, you can relate that over there in the industry, this one is with a switch over here. So you need to deactivate the switch, you need to deactivate the main power in order to open it. If you do not deactivate it, you cannot open it. You have seen that one where over there in the cabinet from the CNC, I don't know if you have seen me opening, but in order to open the cabinet, you need to deactivate the switch. It's not possible to activate the switch if the door is open. So that one uses deactivation. So this one is the main protection for all of the connections that we have in our system. So again, this one is just the main protection. From the main electricity is coming over here, and then from this one we are having a distribution. So that's the reason I was from the question of Mr. Ortega Galindo. Well, you need to reproduce this diagram. So if you want to get the drawing over there in a notebook, that one is the delegate. It's quite the same. Why? Because we have the main triphasic inlet. This one is like the main disconnector that we have is thermomagnetic interrupter. From this one, we have a derivation that is for those three lines over here for this main disconnector or disjuntor, if you want to call it. So from the main power line, we have this derivation that is for this disconnector that is connected to the motor starter. The motor starter is a combination, if you remember, of a contactor and an overload relay. The overload relay for current protection and the contactor in order to have an electrical activation. Because if you remember, we already said that this one over here and this one over here are basically the same. The only difference is that this one over here has an overcurrent internal protection, but it's a mechanical activation. You need to press the button in order to activate it. You need to press the button in order to deactivate it. In comparison, the contactor has an electrical activation. You can send an electrical signal, in this case the start button, in order to activate this contactor. And then, for example, this one is already in a latch configuration. The start-stop, that you press the start, the system starts working. If you release the start, the system continues working. And then until you press the stop, the system stops. So this one is already in that configuration. Over here is a little bit hard in order to see how they perform this configuration, but we're going to explain that one over there. But believe me, that is in a latch. We're going to see it. So again, this one is like a disconnector. With this one, we have an electrical activation. This one is for an overload protection. So if this one over here is like a stop or is getting damaged, and that one is sending a peak of current back to the system, this one over here is going to open and it's going to protect. Well, from all of this one is going to the motor. If we receive a peak of current from this one over here, this one is going to disconnect the energy, and we are going to protect our motor and the rest of our system. So that's the reason we have this connection, all of the elements for the interconnection that we have. Then, if you remember, by the time we were checking AutoCAD Electrical and SolidWorks Electrical, we said that basically we have two systems. Well, like two subsystems, the control section and the power section. Well, the one that I have just explained is the power section, because if you check, this one is the derivation for power in order to derivate it for the motor starter, and then all of this section, including the motor, is the power section. Now, talking about the control section. For the control section, first we need a signal in order to activate the contactor, right? That signal is going to come from the bottom. So we need to derivate a signal in order to energize this section and in order to energize the contactor. How? We can literally take one of those signals over here. Which is the problem? If we take one of the signals over here, by the time we deactivate this disconnector, it's going to disconnect both power and control, and that one is not recommended by no means. You cannot have the same disconnector for power and control. You need to have one for power, this one, and one for control, that is this one over here. So, from one of the lines, you can select the one that you want. If you check over here, we have the reach, and then this one is coming over here for this one. Is indifferent if you select line 1, 2, or 3. From one of the lines, we have this main disconnector. Thermomagnetic switch, just in order to have this connector and thermomagnetic switch. From this thermomagnetic switch, the thing that we're doing is like having one line of power in order to connect the bottoms, in order to, well, the start bottom. If you remember for the starting stuff, I don't have my markers, but you have your notes. May I use it a little bit? May I use this one? If you remember, in general terms, for the start stop, you have this one as a line power. You have one bottom that is going to be the start. You have another one that is normally closed, well, start. Another one that is going to be the stop. I forgot how to write the stop. Stop. You have another one that is your stop, and then you have the main coil that you have from your system. And in order to latch it, you have over here a contact that is going to have this, I don't know, motor coil. This one over here is going to be motor coil. You remember that this one is a latch. So you have your start, you have your stop, normally open, normally closed, your coil, and then a contact of this coil. This configuration is the one that we have over here. So this thermomagnetic switch is like around here, that is connecting this section in order to energize all of your system. Where are we using this coil? Well, this coil is the one of our contactor, and this normally open contact. Over here in this one, if you notice, we have normally open and normally closed contacts. So we are using those contacts in order to get the latch configuration over here with our box. So, I'm sorry. So that one is the configuration that we have over here. So literally from power we have in series to the bottom, and then in series to the start bottom we have the stop bottom. We have one of those normally open contacts in parallel with the start bottom, and then the configuration for the lights. One of the lights is activated when we activate our system, and the other one when we deactivate our system. Basically, that one is the configuration. So that's the reason we have like those two sections. Section for power, main disconnection, section for power, including the motor, and section for control, including the lights and the buttons, right? So, if we activate it, this one is just the main activation. Please don't do it like I did it, because if you notice I did it like this, and that one is the worst possible mistake that you can do. In this one, please, like this, because I almost touched the back part. Even with this one, I feel nothing is going to happen, but I don't want you to get hurt. So I activated this one over here. If I, well, in this one, if you notice, I don't have electricity for this, and we can notice over here that we don't have electricity because we have this one stop and this one stop. So if I activate, well, which one should I activate first? Power or control?
Power.
Control. So in this one, I activate it, and my control section is telling me that everything is just totally in stop. So even like that. What's going to happen if I press stop? Exactly. We need to activate the power. If I activate it, the control is working. This one over here is working, but I don't have electricity over here to the control section. So it's a stop. I activate, this one is just going to let electricity pass over here. If you notice, this one was already working. Could you help me pressing the start? This one is activated. You can listen to it, and well, in my perspective, I can see how this one over here is activated. If you remember, could you press the stop, please? You can notice over here the mechanical activation. Could you press the start? Yeah. So again, in this one, you notice that this one is already working, but you don't have electricity. Could you please help me with the stop? So now, in this one, now we have electricity over here in that section. So if you press start, that one is going to start working. And again, if you press stop, it's done.
Oh.
Yeah. So, any question, issue with this one? Okay, so let's set it up. De-energize. It's because you're going to notice over there in the videos that I always forget to de-energize, and I need to record another video telling you, don't forget to de-energize. Well, I'm going to leave it like this in case you want to observe. I want to